Hello CS112. Today I'll be going over a quick solution to Lab 8, which has to do with dictionaries. Gist of this assignment is that you have 11 children that need to eat, and you also have 11 different foods. You are to use a random operator in order to assign each of these foods randomly to a kid. Now, there are only one of each of these, so each kid can only have one random item. Like two people can't have a sandwich, or two people can't have a nugget, etc. And also, if Lori has pizza, she has to have her food switched with Lincoln's. So that's something we're going to have to keep in mind as well. And when we're assigning each person with whatever food they're going to get at random, we want to create a dictionary with a key value pair, the key being child's name and the value being what food they have. So I'm just going to dive right into it. Again, there were the slides related to Lab 8 were like essentially gave you the code for this assignment. So I'm first going to want to obviously define two lists with 11 kids and the 11 different types of foods, and then I'm going to create just an empty dictionary up here called mydict, which I'm going to be populating with the key value pairs. So I'm going to want to iterate through my keys, which is the kids list. So for I and kids, now I'm iterating through each of these guys. So I'm going to want to set each and every element that I iterate through in kids to be a key in the key value pair here. And the way I do that is, excuse me, the way I do that is I'm going to have my dictionary name, so my dict, and then I'm going to put I in there, and I'm going to set that equal to what I want the value to be. So we will come up with the value in a second, but it's important that this makes sense to you guys. I is going to represent each of the elements within kids, because that's how for loop works. So when you set it like this in a dictionary, that's going to create a key for you, and whatever it's equal to will be its value. So let's just quickly come up with the value here. So they gave you this strip of code to get a random index. So I'm just going to copy and paste that over. So that's going to get a random index based on the range of the list foods, or the range length of the list foods. So it's going to get a random index in here. And I'm going to want to set the value to foods index, because we're still indexing this list at random to get it into my dicts. Now, as I said before, there's only one hamburger, there's only one noodle, stuff like that, so they can't have repeated things. And the way random works, it could potentially yield hot dog or any of these twice within the same index. So what we need to do is, there was a hint here called saying to use pop index to randomly select a food. Well, yeah, you have to use pop index method after you randomly select this index, in order to get rid of that, so you don't accidentally have the same thing. So I'm going to do this after I already assign it to my dictionary, because if I did it before, then I would be messing up the values, like it would be removed before I can assign it. So what I'm going to do is say foods.pop and then index. So what this does is it's just going to remove, it's a list method that will remove index from said list, and it will keep iterating. So it's important that in here, I mean, they gave you this code, but because it's always going to be working with the range length of foods, this right here will decrease the length. So you're always going to be working with the correct range of random indices here. So as of right now, let's just test our code and see what we're at right now. So I'm going to print out my dict. I'm going to save that. I'm going to run it real quick. So Python and then cat.py. And as you can see, I have gotten all 11 names with a unique food. So we were fortunate this time that Lori didn't get pizza, but we will come up with the test case now to sort of do that last part of the assignments. Real quick though, it's important that you guys understand this line. So anytime you want to either create a new key value pair in a dictionary or edit ones, you will use this exact syntax here, where it's the name of your dictionary, the key's name equal to whatever you want the value to be in the key value pair. So if my dict I, for instance, did not exist, it would create a new key value pair where I would be the key and the value would be whatever is on the side of the equal sign. Likewise, if I already existed within my dict, it would overwrite the value and change it. So this does both changing and creating new key value pairs depending on if the key exists or not. So now moving on to this next part here. A way to check if Lori has a pizza or not is simply to say if my dict, and then we can directly access the key Lori because we know it exists. So if that key would yield the value pizza, I'm going to keep it consistent with the double quotes just for the aesthetics. So the way you would access the value of a key is to simply check if this key points or is associated to this value. Then you're going to need to do a swap. Now, a lot of you guys did something along the lines of my dict Lori equals, all right, so I'm going to start copying and pasting soon because I can't type today for some reason. My dict, and then Lincoln, just want to make sure I spell that right. And then you went on to say after that, my dict Lincoln is equal to my dict Lori. Now, it's going to be kind of hard to test this down here because the way with the way random works, while it's not truly random, there is a chance you could, run it 100 times and Lori would never get pizza. But anyways, this right here is not going to switch Lori and Lincoln's food. Let's think about this. Let's think about this line by line. So let's pretend here that Lori equals pizza and what's his name? Lincoln equals taco. So if this line right here, we say Lori equals what Lincoln has. So now when we say that, we're going to say Lori equals Lincoln, which equals taco. So now Lori equals taco. And this next line, we're going to say, all right, well, now we're going to set Lincoln's food to Lori's food. So now Lincoln will equal Lori, which equals taco. So now they both have tacos. So when you're switching things around, you need to have a third sort of holder variable, like something to record whatever Lori had. So we can name it whatever we want. I'm going to try to give it a meaningful name, saying like, I don't know, like Lori old food equals, and then I'm going to set that equal to this, to my dict Lori, before I change it to Lincoln, so I won't lose it, so it can remember what it is. And then at the end here, I'm going to set it back to Lori old food. So what that's going to do is, let me show my example here. So Lori equals pizza and Lincoln equals taco. So what that's going to do this time is, instead of just setting Lori directly to Lincoln and Lincoln to Lori so they both have tacos, what this is going to do is this is going to create a new variable. I'm just going to call it x for now and say x equals pizza. Then when it reads this next line here, it is going to say Lori equals Lincoln. So now Lori is going to equal Lincoln, which equals taco. And then lastly, Lincoln is going to equal Lori's old food, which is pizza, rather than just simply Lori, which would be taco, which they both have taco. So now that's how it's going to work. Now, I do recall that this is a very common thing, especially on like projects where you're going to have to swap things around. So it's very good that you know, it's very important that you know this algorithm. It's a good one. So hold up. I'll try a couple times to see if testing Lori pizza. So I'm going to go ahead and run this a couple times, see if I can actually trigger this branch to be run. If the branch does run, then we'll see this displayed in the terminal. So let's just cross our fingers. So python cat.py, it was not run, it was not run, it was not run, it was not run. Hopefully, yes, we finally got Lori having pizza. So let's check our code now. So as you can see here, Lori has noodles and Lincoln now has pizza. So if we had the code the way before, both Lincoln and Lori would have noodles. So it's good that we were able to test this out and see how it works. If you guys have any questions on these algorithms, the algorithms of switching stuff around, or this line right here, because these are the two kind of biggest points in this lab, feel free to ask on Piazza or just leave a comment somewhere. I'll get back to you.